Hello everyone, my name is Ai-Aria. I'm a graduate student here at the Computer Science, and I'm a lead software engineer and data scientist at Southern California Water Research Project. And today I'll be going over the topic of big data, particularly horizontal scaling. So before we could start that, we have to understand data lakes and data warehouses. Both are tools for use for big data, how to store them. And essentially data lakes and data warehouses are the same thing, the major difference being that data lake can store both unstructured and structured data, whereas data warehouses can only store structured data. So we'll be primarily focusing on data lakes, and it has two forms of scaling, one being horizontal scaling, and the second being vertical scaling. So we'll start with vertical scaling. Vertical scaling just means you have one machine or one node stacking all the data on top of each other. So as we get more and more data, we're just stacking on top. And it's pretty useful because it's all saved on one machine, but the issue is it's gonna eventually reach a max and might crash, which is not a very good thing to have. So using horizontal scaling is a better method. Reason being is horizontal creates more machines or nodes to store data. So instead of having them all on one machine stacked on top of each other, we have it being stacked horizontally, making it a lot faster for the computer, better, creating more servers, and essentially making it all overall better. But one question I had with this is, as we create more and more machines and keep going, what is the probability of failure? So for using it for a small organization or a local network, it might be pretty successful, but let's say we're like somewhere like Google or Facebook or Amazon, for example, that has thousands to millions of data. And with that much data, how many servers or machines are they making, and how will that crash compared to that? So it brings me to the question of probability. So as we all know, the probability of failure for one of these servers to crash, so just one server, is only 0.001%, which is pretty low. And the formula for calculating this is probability of failure, oh, my mistake, 1 minus the probability of failure to the 1 over n power. And n, I should probably define over here, n is nearly just the cluster or number of servers we have. And to understand this big data, when we're sending it to the data lakehouse, we're actually using something called data sharding. And data sharding is this management tool that basically fractures off the data and sends it to a particular server. So all servers are saved to one place. So now that we have this understanding, let's calculate this into this formula. So 1 minus 0.001, and let's say our n is 1,000, for example. 1 over 1,000, we have 1,000 servers. We calculate that in, we have this will equal 0.999 to the 1,000 server. And once we calculate that, we'll see that it equals closer to 1. So now we can compare this and understand that the probability of failure has increased so much from the original 1 server, which was less than a percentage, to almost being up to a percentage now. So to see this on a graphical view, so percentage of failure, let's say this is 1 here, we'll see that the graph is exponentially getting higher to failure. So this is percentage of chance of failure, and this is number of clusters, or number of n increasing. So the more servers we get, the higher chance of failure will occur. So let's say if we have over 1,000 servers, there's a high probability one or more of these servers will crash. So this might seem very high level, so I'm going to try to break this down to a simpler form to just understand, and we can use that by understanding the probability of flipping a coin. So we'll have the same formula here. Probability of failure, 1 to the n power. Okay, so we have, I guess in this case it would just be to the nth power. But to have a chance of failure, or not failure, the chance to flip a coin is a 1 out of 2 chance. As we all know, if you flip a coin, it'll be 50% chance head or 50% tail. Well, if we flip that coin twice, so we'll answer this into that, n equaling 2, because that's the number of times we're flipping. So we already know, we get this as, let's see, 2 over 2 minus 1 over 2 to the second power. You got 1 over 2, and the second power is, you have a 1/4 chance possibility of flipping heads twice. So I hope this explained a little bit about big data and gives you a better understanding of how it works and the probability of failure. So thank you again. Like I said, my name is Ai-Aria. If you have any questions, please provide them on the comment section and I'll try to answer my best I can. Thank you.